Okay, good day. Hope that you're all well. Just wanted to make a video here discussing some equation laws. This is a primer for people who have never done equations before, but also a reminder of good habits and good skills for people who have done equations before. Okay, so first of all, we need to acknowledge that there's two mathematical realities that we have to align with whenever we're trying to solve an equation. Okay, first of all, anything in math that we can do, we can undo. Okay, so let's say that I give you 2 apples. I can easily undo this operation by taking away 2 apples. So if I add 2 apples and I want to get rid of this plus 2, I can simply subtract 2. Okay, so we have our idea of doing something and then undoing that something. Likewise, if I take 2 apples away from you, I can undo that by adding 2 apples. So, once again, everything that we can do in math, we can undo. Okay. Secondly, whenever we're dealing with an equal to sign, not a lot of us think about what this equal to sign actually means. Right? So an equal to sign means that what is on this side, okay, our left-hand side, is equivalent to what is on the right-hand side. Okay, so for example, I could just write it as simply 8 is equal to 8. This makes mathematical sense, right? But so does 2 times 4 is equal to 8. Okay, you agree with me? So we can see that our left-hand side, even though it's not exactly the same, it is equivalent to our right-hand side. Okay? Now with that in mind, with the idea that whatever we can do in math we can undo, if I look at this operation here, I can see that this 2 is doing something to this 4. Okay? And the operation being applied here is multiplication. If I want to get rid of that multiplication, I can divide this side by 2. Okay? Which means that I now have an equation where 4 is equal to 8. And that does not make any sense at all. So what we realize is that if I do something on the one side, I have to do the exact same thing on the other side as well. Okay? So we see that 8 divided by 2. So 4 is equal to 8 divided by 2, and I think we can agree that these two are equivalent. Okay? So bear with me for the guys that are here to just sort of practice and get some greater knowledge in. We are just going to go through some basic stuff, but it's important that this basic stuff is understood. Okay? So now we have an equation, x plus 2 equals 5. Okay? And we have to think about the fact that we have, firstly, we have our left-hand side being equivalent to our right-hand side, and that we have our mathematical principle that if I add 2 to one side, okay, if I want to get rid of that plus 2, I can minus 2. Okay? And if I do that on one side, I have to do it on the other side as well. Okay? So when we read this equation, what we are actually reading it is a certain number, okay, a certain unknown number, plus 2 is equal to 5. Okay, so a lot of us, if we had to think about it, we can muscle this through and we can say, well, the only number that I can add 2 to that equals 5 is 3. Therefore, x is equal to 3. Okay, but how do we get there? Some of you might have been taught that all you need to do is you need to take the 2, take it to the other side of the equation, and then change the sign. Okay, so I go minus 2. While you will get to the correct answer in this case, this is mathematically not very authentic, and it means that when you get to more difficult sums, you're not going to be equipped to handle them. Okay, that's why we've got to look back at those 2 fundamental rules I introduced at the beginning of the video. So what I'm going to do is first, I'm going to ask myself, what operation is being applied to x? Because ultimately what I want is I want x to be by itself. So what operation is being applied to x here? Okay, well, we are adding 2. Okay, so I want to get rid of plus 2. The inverse operation, the opposite operation of addition, is subtraction. So once I've identified my operation, I can then identify the inverse operation. Okay, so the inverse operation of plus is minus, and because I'm trying to get rid of 2, I can go minus 2. And if I'm minus 2 on one side of the equation, I have to minus 2 on the other side of the equation. Okay. Now you might be wondering, well, why can't we just skip all of that and simply just take it over the other side? It's a lot easier, it's a lot quicker. Well, what happens if I get something that looks like this? Okay, we can now see that we're dealing with a more complex sum. And the rule of simply taking the number over and changing the sign doesn't really work here, because there's so many things happening at once. So you want to take the 2 over and you're going to change the sign. Well, what's the sign of 2? And a lot of people are going to forget that this is actually positive 2, first of all. But second of all, it's not really mathematically authentic. Okay, so let's unpack this step by step. How would I go about solving this? Okay, so the first thing I want to do is I want to get rid of divide by 4. Remember, a fraction is equivalent to division. So I want to get rid of divide by 4. The opposite operation of division is multiplication. Okay, so when I want to get rid of this divide by 4, I'm going to multiply. Okay, and remember, when we wanted to get rid of plus 2, we said minus 2. So if I want to get rid of divide by 4, I must multiply by 4. Okay, and there's some fraction stuff that we can go into here, but for now, at least in terms of this video, I'll probably make another video on fractions later on. In terms of this video, we have 4 over 1 times by it, and because we have 4 over 1, this 4 cancels with this 4 here. Okay, but because I multiplied this side by 4, this equal to sign means that I have to multiply this side by 4 as well. Okay, and we have 8 times by 4. 8 times by 2 is 16, times by 2 is 32. 8 times by 4 is 32, and I have 2 plus the square root of 5 plus x. Okay, and at this point it's a little bit easier for us. We might not think that it's easier for us, but we just take it step by step. We don't want to, whenever we look at math, we want to try and break it down to simple parts. So the next thing I want to do is I want to get rid of this 2. Okay, so I'll ask myself, what is this 2 doing? Okay, well, this 2 is positive 2, and to get rid of positive 2, I must subtract 2. Okay, because if you have 2 apples and I want to get rid of 2 apples, I must subtract 2 apples. And what I do on one side, I must do to the other side as well. Okay, hopefully that makes some sense. Now I have 5 plus x equals 30. Okay, 5 plus x equals 30. And now I want to get rid of the square root of 5 plus x equals 30. Okay, I want to get rid of the square root here. Okay, and this is where things sort of start to fall apart a little bit. Oftentimes people get confused by something like this, but don't worry. What is a square root? Okay, what is the operation of a square root, and what is the opposite operation of a square root? Okay, so if we look at it, the opposite operation of a square root is a square. Okay, so a square will oppose a square root. Okay, so all I do is I'm going to square this side, I'm going to square this side, and now I have 5 plus x equals 30 squared. Okay, and we can calculate this as 900, and now I have 5 plus x equals 900. Okay, and now I want to get rid of the 5, and all I'm going to say is, well, once again, I'm adding 5 here. Okay, be careful, we don't look at this sign, we're looking at the sign in front of the 5, and because there's no sign, we assume it's addition. Okay, and I'm going to go minus 5, minus 5. X equals 800, and 95. Okay, does that make sense? We see how we've sort of unpacked it here. We've taken something that is quite complex, we've unpacked it, and we've taken it step by step, okay? And this is how we need to apply equations. And this is true no matter how difficult an equation gets. Always look at what is happening and see if you can cancel that thing out, okay? This is true of addition, subtraction, multiplication. So we need to know our inverse operations. So addition and subtraction, multiplication and division. We can think of squaring and square rooting. Okay, this is also true then of cubes and cube roots and so on and so forth. Okay, and there's a few other stuff like logs, anti-logs, whatever else. But for now, these are the most important ones to sort of keep in mind. Okay, I hope that video is helpful, a little tutorial. It's small things that you can remember, and you can just go step by step. And really your steps are, first of all, you want to see what you are doing, what operation is being applied, and how do we get rid of that operation. Because at the end of the day, when we're trying to solve equations, we're trying to isolate x. We're trying to get x by itself. And in this method of isolating x, we solve for x, and this is what we want. Anyway, thank you so much for your time, and I hope that you enjoy the rest of your day.